So today we are going to talk about multiplying binomials and also factoring to find the binomials. So let's get started. So we're going to start out with this binomial, x plus 2 times x plus 1. And I always like to use just this pattern for this, but you can print off these work mats underneath the algebra tiles, and this is a great one to have. One of the things, if I have a student who has some issues with being able to organize their stuff, I like to put a wiki stick on here, so sometimes I'll do that, and I'll put a wiki stick on there just so they have a bumper to be able to lay their stuff on. But for today, I'm just going to do it this way. Another thing is I may color code my X's so that they can see them better. I may have them to color code their X's just so that they understand what they're looking for. So at the top is where I'm going to start this one. I'm going to always put at the top. So x plus 2, and those are all positive. So this is what it's going to look like. I'm just going to lay them on this line. And then x plus 1. So again, going down, we'll have x, and I'm going to put it this way. The reason I'm putting it this way is you see that falls right in for that x squared to be able to fit right in there, right? So you can see that, and so x plus 1, let's go ahead and get that in there. Now, if you notice, I'm building a square at this point, and I talk to my students that this always has to come out to be a square. So, or not a square, but a rectangle. I am building a rectangle, and it's always going to come out to be a rectangle. So this is extremely important that they know that if they don't have a rectangle, it is not correct. So for this one, x times x is x squared. This is 1 times x, which is 1x, because that's what fits in there, in that spot. Now, this is 1 times x, which is x. Again, 1 times x, which is x. Now, as you notice, I've got this spot here. Like I said, this is not a good rectangle yet because I have this spot. So now it's 1 times 1 is 1. 1 times 1 is 1. So, or in this case, you could say 2 times 1 is 2. And that's another way that they could look at it. So if I go back, what did I do here? Well, I said x times x. So we multiplied these. And then I said, oh, x times 1. So x times 1. And then I put that here, right? Now I said x times the 2. So now I move back and I did x times 2. And last I did the 2 times the 1. So we can start to see that full method develop here. But this is also, if you think about it, when we do multiplication and we have the students do it as 30 times 2 and 20 times 4, and they go in and they do this, and they go, oh, this is 120, this is 600, this is 40, this is 8, and then they just add those together. It's the same. They've seen this before. That's what I like about it. And if we need to, we can have them later to draw this, and they can do x plus 2, x plus 1. Go ahead and put this in here. This is x squared. This is 2x. This is 1x. This is 2. Now I combine my like terms. These two are like terms. And I have 2x plus, 1x and x squared and 2. And like I said, I combine my like terms. This is 3x plus 2 and x squared. And there's my answer. So they can see that again. Do I have that here? Absolutely. I have x squared, which is here. I have 1, 2, 3 x's, and I have 2. And they can pull these back if they need to, so they only see that. Like I said, that's really why I like to have that wiki stick laying there for my students, because they can literally pull those back and see the square. So let's do another one. So our next binomial is x minus 3, x plus 1. Again, we have our little mat here. And so I'm going to go ahead and across the top, x minus 3, so that's going to be negative 3's. And then down the side is my x, which is positive, plus 1. Now this is where, if we've done it enough with negative and positives, they understand what's going to happen here. So of course, x times x is x squared. X times 1 is 1x. Now 1 times negative x is a negative x. 1 times negative 1 times x is a negative x. And a negative 1 times x is a negative x. Now I have a negative and a positive, of course, so now it becomes a negative 1, a negative 1, and a negative 1. Pull these back, and I can look at it, and I can say, okay, what do I have here? In this part, we can talk about zero pairs. Do I have any zero pairs? I do. And I can move these away, and I can now do x squared plus, I can do a negative 2x, or I can say x squared subtract 2x and subtract 3 or plus negative 3. Now, let's look back at this and let's talk about that FOIL method that we just did. I can say x minus 3 and x plus 1. X and x is x squared. And subtract 3x, right? And I can go ahead and do x plus 1 plus 1x, right? X, and then of course my 3 to my 1, I'm doing that. I'm going to have subtract 3. Now for multiplication, if I go in here and I do my like terms, this is going to be so when I did this up here, I did the same thing by combining my like terms, moving them away. What do I have? And so you can see this. I like the fact that I'm color coded. I see the things that are the same. This is very important for our students. Let's do a different one. So what does it mean, x plus 3 squared? It means we're going to have 2 of those, right? So I'm going to have x plus 3 and x plus 3, putting them in parentheses. Now again, like I said, these are positive, so here we go. Positive plus 3, 1, 2, 3, and I'm going to do the same down this way. Plus 3. And now it is time to build. So an x times an x is an x squared. An x times 1 is 1x. An x times 1 is 1x. And x times 1 is 1x. So those are put in there. Now, 1 times x 1x. 1 times x is 1x. 1 times x is 1x. Building it. Now we come to our ones. 1 times 1. We know all of those are 1. We're just going to fill this in. 1 times 1, 1 times 1. Again, 1 times 1. They're all positive, so we don't have to worry about that. Go ahead and just fill this in to make my rectangle here. Fill in my rectangle with these little ones. Like I said, I can move these away. And we can show the full method as we're doing it. So what happened? X times x gave me x. So if I do that over here, and I'll just do the full method for you. So I did x times x was x squared. I did x times 3, which gave me 3 x's. Now I did 3 times x, which gave me 3 x's. And then I did 3 times 3, which gave me 9. I combine my like terms again. So in this case, x squared is by itself. I combine my like terms right here, and I have 1, 2, 3, 4, 5, 6, 6x. They're all positive, and I had this looking very pretty as a great square, and that was 9. So like I said, you can see the full method. We can see how we combined our like terms. It's right there for us. We'll love this.